design of the clock sequential circuit from the state diagram. This is really very important. Suppose uh, what we have done up to this point, what we have done, if I know the sequential circuit, based on that sequential circuit, I can make the state or the characteristics table, and then from that characteristics table, I can make the state diagram. Let me repeat again what we did here. As of now, what we have done, suppose I have a sequential circuit. Based on that, I used to prepare the characteristics table, and from that characteristics table, I can make the state diagram. Okay, so this is what we have done in the Mealy and the Murray sequential circuit. But if I want to make it opposite, okay, opposite means what? Suppose I already have a state diagram, and I want to make a circuit out of it, okay, in opposite direction. So how we can do that? What is the process to to design a sequential circuit from the state diagram? Okay, so for that purpose, we need to follow some of the regulations, some of the algorithm is need to be followed. I'm not explaining any of the steps here. Directly, I will take one example, and then I will tell you how to do that. Okay, so whatever the steps here I have written over here, these all the steps will be followed when I will take the example. Okay, so let me take the example, then I will make the circuit for this one. Okay, so see, the major objective of designing the sequential circuit based on the state diagram is to design a circuit if the state diagram is given. Okay, so let us try to do that. Suppose, let us take the example. Suppose I have a state diagram which is given like this. Okay, here I have a 4 states, 0 0 0 1 1 0 and 1 1. Okay, and considering like 0 0 is nothing but this is a1 a0. Okay, is the nomenclature, like for two variables 0 0 0 1 1 0 and 1 1 is given. Okay, so I have a 4 states, and accordingly the state diagram is given something like this. Okay, so if the state diagram is given, let us try to see how I can come up with the sequential circuit from this state diagram. Okay, so what steps I need to follow? The first step is to prepare the state table. Okay, the first step is to prepare the state table, and state table will be prepared based on the inputs. Like let us assume the present state is in form of a1 a0. So the present state can be 0 0. So this indicates 0 0. 0 1, this indicates 0 1, 1 0 and 1 1. So these all are the present states whatever I have. Now let us talk about the next state. Okay, what is the next state? If present state is 0 0, and if input is equal to 0, then the next state is 0 0. What it indicates, what this arrow indicates? This arrow indicates if x is equal to 0, then the next state is again 0 0. Okay, so if x is equal to 0, so the next state is again 0 0. Now let us see this case. If x is equal to 1 and the present state is 0 0, so this is the present state, and x is equal to 1, so it is moving from here to here. Okay, so this is the arrow which belongs, and the next state is becoming like 0 and 1. Okay, so this is how we can prepare. If you have any doubt at this point, you can ask the question, and similarly I can prepare for others. Okay, so present state is 0 0, x is equal to 0, next state is 0 0. So x is equal to 0, next state is 0 0. X is equal to 1, next state is 0 1. So this is how it has been made. Now let us consider the present state 0 1. So I need to consider this point. At this point, if the present if x is equal to 0, then it is moving to 1 0. So I need to write 1 0 over here. And if it is 1, then it will maintain the same logic, which is the 0 1. Similarly, for others, like if I have a present state 1 0, and if I have given x is equal to 0, then it will maintain the same logic, which is the 1 0. And if it is 1, then it will move to the next state, which is the 1 1. So this is the next state. Similarly, suppose I have the present state, which is the 1 1, and if x is equal to 0, I will get the same logic, which is the 1 1, And if x is equal to 1, it will switch to 0, 0 if x is equal to 1. So this is how I can prepare this state table based on this state diagram. Okay. So if anyone has any doubt at this point, you can ask the question. Okay. Now, the next step is like the preparation of the excitation table. Okay, preparation of the excitation table. Yeah, here I can have like based on x and based on the a b, I can have total 8 possibilities. Like a and b has 4 groups, like 0 0 0 1 1 0 1 1, and I have a x is equal to 0 and x is equal to 1. So I just represented this table in the other form, and this is how we can make it. Okay, so the input and the present states are given something like this. Once we are ready like this, let us try to see what next state we can write. Okay, so simply what I have to do, because x is equal to 0, so these groups belongs to x is equal to 0. Okay, so simply this table or these two columns will be replicated, because this is equal to x equal to 0, and a1 and a0 are something like 0 0 0 1 1 0 and 1 1. So if it is like that, I have to simply replicate this here. Okay, so after replicating this, let us try to see what will be the table, like 0 0 1 0 1 1 and 1 0 and 1 1. And for the lower two fourth one, this one will be the replicated, because it is x equal to 1 and this belongs to x equal to 1. So this will be 0 1 0 1 1 1 and 0 0. Okay, so this is how we can make the table based on the things which we have given. Now, one important thing is required, because design a sequential circuit, because any of the flip-flop is not given, but because here I have considered the JK flip-flop, you can consider anything. The question may be given something like design a sequential circuit whose state with the help of JK flip-flop, and the state table, a state diagram is given something like this. So I will use the JK flip-flop. Okay, so anything can be given, any of the flip-flop can be given, because here I have just prepared based on the JK flip-flop. I'm considering I want to make this sequential circuit with the help of JK flip-flop. So I need to find the excitation of JK flip-flop only. Okay, so because and how many flip-flop will be needed? Because I have a 2-bit, I need 2 flip-flop. Okay, so this is how we decide how many flip-flops are needed. And if I have 2 JK flip-flops, so there may be JA1, KA1, these are the input of one of the flip-flop, and JA0 and the KA0 is another input. Okay, so these two are the inputs and other things. Now let us try to see how we can prepare these tables. Okay, so to prepare this table, we need to use the excitation table of the flip-flop. We know that present input in the next input, based on that I used to decide the J and the K. Okay, so let us first consider for A1. So I need to consider with respect to A1, I need to prepare a table for J. Okay, so the JA1 indicates I am preparing the table for A1 and for J. Okay, so this A1 and this A1 will be considered to prepare the JA1. Let me repeat it again what I'm saying. To prepare this excitation table, I need the present state and the next state, and the J will be created. J I need to prepare. Okay, so here I have a 2 present states, A1 and A0, and if I want to make the input for J based on A1, so I need to consider A1 from the present, A1 from the next, and I need to prepare for J, so I am referring it to JA1. Okay, so see here, 0 and the 0, 0 and the 0, J will give you the 0. So J will be 0 if the both are 0. 0 and 1, 0 and 1, J will become 1. 0 and 1. Okay, next 1 and 1, 1 and 1. Yeah, so let me change the color, otherwise there will be a problem. Okay, so this was 0 1, we have already calculated it. Let us try to see here. A1 for this present A1 is the 1, next A1 is 1. So for 1 and 1, this is the don't care. Okay, similarly 1 1, don't care. 0 0, this is 0. Okay, then 0 0, this is 0. Then don't care and don't care. Similarly, just following all this thing for K and the A1 and A0 and other things, you can simply prepare this table. So I'm just preparing it directly because this is easily doable. It's not that much difficult. So we can prepare the table for anything, whatever we have. So let us try to prepare it. So let me try to prepare the table for K. So this will be cross 0 0 cross 0 and 1. Similarly for A0, so I need to consider this one and this one, and based on that I need to prepare for J and the K. Okay, so if I'm considering these two and I'm preparing these things, so the table will be something like 0 cross 1 cross 1 0 cross I think there is some mistake. 0, it will come something like 0 cross, and then 0, this is the J. ठीक है, 0 1 0, this is cross, fine. The next one will be like 0 cross 1 cross 1 and cross, and the other one will be like cross 1 cross, this is simply opposite to this J, right? Cross 1 cross 1 cross 1 cross 1 cross 0 cross 0. So this will be the table for JA1 KA1 JA0 KA0. I'm just giving 1 minute time to think about this one. If you have any doubt at this point, you can ask the question. How I just prepared this excitation table, excitation of flip-flop. This is just simply, if I'm considering for A1, so I need to consider A1 and A1 for the past and the present input, and I need to consider this table to prepare for J.
Excuse me.
Yeah, please.
Sir, the KA0, in the KA0, the fourth one and the last one are wrong.
Fourth one and the last one. You're saying this one and this one?
Yes, sir.
Okay, let me check it out. For A0, right? So I need to consider this one and this one, and one that gives 0. Yes, perfect. Yeah, this will give you the 0. And if we talk about this one, 1 and 0, so 1 0 will give you the 1. Yeah, sorry. Yeah. So this will be how it will look like. Okay. So this is how you can just prepare based on the table given over here. Okay. Now, what is the next step? I will take 2 more minutes and I will finish it up, right? So, so once we are ready with this one, so I need to write these functions like JA1, JA0. So the JA1 is a function of X, A1, A0, and this is nothing but the minterm 1 is the 1, and the 2, 3, 6, 7 are the don't care. Similarly, KA1, I can write minterm 7 is the high, and rest 0, 1, 4, 5 are the don't care. JA0, the minterm 4 and 6 are high, and for KA0, minterms 1 and 7 are high. Okay, so this is how we can write this JA1, KA1, JA0, and KA0. Okay, so this is how it is doable. Once we are ready with this, all these things, what I need to do, I need to solve the K-map for this one. Okay, so remember for JA1, 1, 2, 3, 6, 7 is there. So let us try to remember it, and then we can solve the K-map. So let us try to solve the K-map for JA1. And if you can remember, JA1 is nothing but the minterm 1 is there. Okay, so 1 minterm is high, and 2, 3, 6, 7 are don't care. 2, 3, 6, and 7 are don't care. Similarly, if we talk about KA1, for KA1, 7 was high and 0, 1, 4, 5 was don't care. Okay, so 0, 1, 4, 5 was don't care. Okay, similarly, if we can see the JA naught, JA naught was the 4 and 6 was high. Okay, and 1, 3, 5, 7 was don't care. 1, 3, 5, 7 was in don't care state. The last one is like KA0. In the KA0, 1 and 7 was high, and 0, 2, and 4 and 6 was in don't care state. Okay, now let us try to make pair. So in this one, I can make pair with this. If you see here, I can make pair with this one. Here I can make a quad over here. So this is possible. And here I can make 2 pairs. Okay, so 2 pairs are possible. So if you try to see here, JA1 is nothing but this is the X bar A naught. KA1 is nothing but this is the X and A naught. And if you see JA0, this is nothing but this is like X, and KA0, this is, we are getting 2 things. The one thing is like X bar A1 bar plus X into A1. Okay, and if you see here, X and A1 are nothing but they are XNORing kind of thing. Right? See here. So this is nothing but X XNOR A1. Okay, so this is how we can make it. Now, based on this one, like here I have a JA1, KA1, JA0, KA0, whatever the expression I have, just I need to connect all the things. Like here I need one AND gate, here I need one AND gate, here I do not need anything, here I need one XOR gate, and then based on that, after connecting all these things, I will get the actual circuit requirement for this purpose. Okay, so this is all about how we can design it. Okay, so this is the tutorial question on this one, and that's it all about the sequential circuit design.